I'm back. This is Kiran. This is related to basic image processing. This session is basically for only who are interested and to know interested image processing and behind the scenes processes, and also who are already known and who are expertise. This session is not useful, not at all useful. So now basically we earlier I have explained how to execute the basic programming and how to load the image and display the image and destroy the image. Destroy the image means sense need to close the image and by programmatically. Now this is the where we need to create our own image with different colors. We can say it's not about the concentrating on the creating the image and colors and all those things. Now basically this session is how the behind the scenes the image is processing by using the OpenCV APIs and the libraries. Now as usually I'm going to explain about the, as this is a basic session and basic introductions, so I'm going to teach again what is the headers and the namespace. Now it is we need to include the header files and also inbuilt streams, so which we need to include those files, those functionalities which are inbuilt. Now this is related to CV and STD. Those are all namespace and encapsulates associated logic. For example, here the CV consists of whatever the image processing inbuilt functions and methods. Objects like, for example, MAT. MAT is a object which holds the image, and it contains the it holds the channels which are already I explained those things, but this is very much relevant to that channels and the image. Now again I am recalling that session. The data types of arrays basically contains the channel. Now CV8U is a 8-bit unsigned integer, like CV8U is a one channel. So here 8-bit, each cell contains the 8-bit, that means 0 to 255. So we can contain, it represents each pixel is contained the 0 to 255. Like that, it is the size of the pixel, not the size of the image, is 5 by 4. So 5 columns, and height is the 5 by 5. Here it is the 5 by 5 because height and width are same. Like this, this is a one channel. And now coming to the color, there is a black and white. Now it is a color. It is contain the tuple. So it is a 5 channel ECV8U C3. 3 means we have it. Each channel is nothing but one matrix. Now it is having a 3. Now it is having 3 matrices. Matrix 1, 2, 3. So each combination 54, 0, 34 is a one tuple which represents the color. Now like that, 58, 78 and 145 is also one array. So it is the image of the color image represents in this way in the behind the scenes. So image depth is 8-bit, the image consists of a single channel. This is a single channel. I'm about to describe about the single channel, and 4 pixels is height, 1, 2, 3, 4, and width is 1, 2, 3 is 5. Now the resolution which we call is a 5 by 4. It's a 5 by 4 matrix. So in this way the color image, that means the color, now it is only single matrix. So if we have a 3 matrix which represents the blue, green, red, so then that is a color image. The color image represents in this way, in the red, green and blue, 255 in the starting, red and the green in the middle and blue in the end. So in this way the colors will represent, and these are the 3 matrices. It is the behind the scenes of a image, how the color image appears. If it is alpha, then again another matrix will appear, that is a mask. So this is all called a behind. This is entire represents how the image and the color image represents. Now going to the implementation, that means a coding. As usual, here you can see this is a 600 columns. Like earlier I have mentioned, the 5 by 4 you have seen. 800 is a height, and 800 is height, and 600 is a width. So 6 by 8, it is nothing but a resolution. Sorry, 800 by 600, there is a resolution. Here 600 is height, you can see, and 800 is a width. Then C by R in the matrix. This is the mathematics behind the scenes examples of the matrix. So matrix, in earlier in the school or college and graduation, post graduation, we used to learn mathematics, but we don't where we real time we will use. This is one small, very small example, that is the huge uses of mathematics. So this is one of the example we can see here. Now this is CV_8U3. This is a 3 channel and 8-bit. This is a 8-bit and 3 channel. So it contains a 3 channel. 3 channel is nothing but blue, green, red. Now we are preparing the 3 channel, and the resolution is 800 by 600, nothing but 800 width, 600 height. Now this is fine, we have understand up to this part. Now scalar. The scalar is nothing but, here it's a matrix, but I don't want to go into much. Now scalar is a tuple. Now we are assigning into the function of the image function is nothing but a mat, which we are assigning all the cells, nothing but 100, 50, 30. We are assigning all the tuples of this matrix. All the tuples of this matrix we are assigning to 100 to 50, 30, 100 to 50, 30, 100 to 50, 30. So entire image is occupied with the 100 to 50, 30 color. So consistency everywhere, that color is appear, so that it finally into the same color. Now these are all remaining things are same, like window name and name of the window, and we are constructing the name of the window, and this is a function I am sure. So this is image show the function, which is namespace encapsulated with the namespace CV, and we will use by calling by CV namespace. And so Windows name and image, and this is nothing but a mat object we are sending. This is a default wait key that contains CV. So this is another destroy window function. Is closes window, that's it. Return 0, we are returning 0. Not much explanation required for this. I'm going to execute this code. Yeah, see, everywhere in each cell is occupied with 100 to 50, 30. So consistency you're getting finally this color. Happy coding. and image processing. Welcome to the huge world.